Okay, so today we're going to review for individual test 3. I'm just going to show you some different types of problems. The first one is an absolute value equation. Recall that absolute value means the distance away from 0. So I need to find numbers that are going to work in here that will result in 5 units away from 0. I can turn this into two problems. 2x plus 1 equals negative 5, 2x plus 1 equals 5, and then just solve them. So x equals 2 and x equals negative 3. This one over here, we need to get rid of this denominator down here. So I can do that by multiplying all of my terms. There's 3 objects here, one here, one here, and one here, by 8. So when I multiply this by 8, these cancel out and I end up with 7x. When I multiply this one by 8, these cancel out. I end up with negative 3. And when I multiply 5 by 8, nothing cancels out, and I get 40. Go ahead and add 3 to both sides. 7x equals 43, divide by 7, and you can leave it as 43 over 7. Otherwise, it'd be some sort of decimal, probably 6 point something. Okay, this one over here, I have a power equal to a power. Whenever we have this situation, we need to get a common base. 16 squared is way over 64, so that means that I need to find a number smaller that these can go into. So for instance, 4 squared is 16. So 4 squared is 16, you bring the x down right here and put it next door. Equals, and 4 cubed is 64. So again, this x is coming down from here, the 4 cubed is 64. Now that I have the same base, I can set my exponents equal to each other. So 3x equals 2x, I solve, subtract 2x on both sides, so x equals 0. And that should make sense to you because any other number I put in here is just not going to work, right? 64 to the first power is 64, this would be 16. They don't equal. The only time they're going to equal each other is when 0 is right here, because anything to the 0 is 1, so they both end up being 1. All right, this one, x to the 1/3 equals 7. That's the same as taking the third root of x. I need to undo that. So to undo that, I'm going to cube both sides. So x equals 7 cubed, x equals 343 if you used your calculator or if you figured it out. 7 times 7 times 7. All right, next group. These here, we need to simplify each expression. So dealing with this one up here, I'm going to simplify things just object by object. So first of all, I'm looking at this 5 over 15. 5 over 15 reduces to 1/3. So I took care of the 5's. Now I'm going to deal with the v's. I have 5 v's on top, 7 on the bottom. Cross things off. I end up with 2 v's on the bottom. Now with the w's, I have 3 w's on top, 2 on the bottom, cross things off, end up with 1 on top. So you can leave it like that as 1w over 3v squared. Otherwise, you could write it as w over 3v squared. Okay, this one here, I don't want any negative exponents. Typically, your directions would state that this one does not. So we need to rewrite this so that we don't have any negative exponents. So this one here, remember that this is all over 1, right? Anything divided by 1 is the anything. So this is going to move down, and everybody else is going to stay put because they have positive exponents. So x to the 4th, z to the 5th, all over y to the 3rd. Okay, this one here will not be as interesting as it is here on the test. So we're going to walk through this one, but it will be more like a square root of this stuff here and not here because this one doesn't go nicely. So we're going to, again, take it in pieces. The square root of 225 is 15. The square root of m to the 6th. So something times something is m to the 6th. So we know we're going to need m's. And it turns out to be third. M to the 3rd times m to the 3rd is m to the 6th, right? 1, 2, 3, 4, 5, 6. So when I square root that, it's m to the 3rd. This one here, he's a little interesting here. I can break this apart into n squared times n. The square root of n squared is n, and this guy's just left over. And like I said, if this is a little fuzzy right now, that's okay. We actually spend a whole chapter on these later on. So truthfully, this question should not be on the test, or at least not this part right here. So your question on the test will look more like this, the square root of 225 m to the 6th. Because these actually break apart nicely. So this is 15 and that's m cubed. So like if I did another one here on the side real quick, the square root of 16, x to the 8th. We can do that easily. So square root of 16 is 4, and then what times what is x to the 8th? That's x to the 4th. You check that. X to the 4th times x to the 4th is x to the 8th. And 4 times 4 is 16. All right, so here's our answer for that one. Okay, this one here, we need to simplify this further. So here's m to the 4th, and then I have m to the 3rd twice, right? There's 2 of these, so twice. And you just count them all up. So here's 4, 5, 6, 7, 8, 9, 10. That's it for those. All right, last problem. So this is kind of one of the last sections in chapter 3. We need to factor everywhere. Before we factor, we need to realize that we're dividing. So when you divide in fraction world, you flip the second one. So this one's going to flip upside down and be multiplied. So I'm going to put my 4x minus 1 on the bottom right away because it's flipping because of the division. I'm also going to put these in parentheses right away because it is a group. Also, I'm going to copy down the 5x minus 2. That's a group. And now we're going to start factoring. I always start with my easiest ones first. And like this one here and this one here are easier to factor than these two because sometimes these factors here help me with the harder ones. So let's factor this one. I need two numbers that multiply to negative 36 that are 5 away from each other. So x plus 9 and x minus 4. Right? 9 times negative 4 is negative 36. 9 plus negative 4 is positive 5. Over here, I need two numbers that multiply to negative 27 that are 6 away from each other. So 9 times negative 3 is negative 27. 9 minus 3 is 6. You can see some things are going to start canceling out over here. Now I'm over here. I'm going to use this one. You see the 4 here? I'm going to use this 4x minus 1 and see if that'll help me. All right, so 4x times what gives me 4x squared? That'll be x. Negative 1 times what will give me 3? Negative 3. So we're going to check it real quick. Here's 4x squared. 4x times negative 3 is negative 12x. Negative 1 times x is negative 1x. Sure enough, there's my negative 13. And then this plus 3, so it works. Again, we're hoping that this one here is in this one because of the 5s. So we're going to put 5x minus 2 here. 5x squared, I need 5x times x to get that. Negative 10, I need negative 2 times negative 5 to get that. So again, check real quick. Here's 5x squared. Here's, actually it's positive. See, that's why we check. Because negative times positive is a negative. 5 times 5 is 25x. And negative 2x. And sure enough, there's 23x, which is right there. So it works. And then that's negative 10. All right, now that everybody's all factored, you can cross off like blobs, if you will. So there's one there, and there, there, and there. X plus 9 goes away, and x minus 3 goes away. And so now you just write what you have left in their same location. So this one's in the top row, it stays in the top. This one's in the bottom row, it stays in the bottom. And that is how you do that problem. That's it. Thank you.